Hey guys, sorry for the interrupt, but had a page from base camp. Got an invite for snacks and afternoon buffet and a football game, so hey, Sunday's looking up. Alright, well where were we? We're talking about MDF and HDF because all we mill up here, as we said, was wood. I do a little bit of composite and plastics, but 99.9% of the time it's wood. Alright, well, MDF and high-density fiberboard are basically, in my opinion, like I was saying, it's a mixture of wood pulp, some gluey resins, wax, and, like I said, urea formaldehyde. The stuff is awful. Protect yourself. Don't breathe this stuff in, okay? And how it's basically made, it's poured in the molds, pressure is applied to it, depending upon medium density and high density or heavy density fiberboard. It's the amount of pressure that's used. Similar to that in, like I was saying, like a press brake or something like that. The amount of pressure that's used creates the density of the material itself. Alright. Well, our next step here is we've made our lines, we've marked, we've drilled our holes, our clamps have held our material in place. Like I said, I've only thrown three clamps on here. I would use at least 2 clamps per track. You can use 3 if you want, but 2 is sufficient. And the nice thing is each clamp will hold each side of the material. So you're applying even pressure all the way around. Great. Now, once everything is fastened down, and this could be done in the machine, but by the time you cut the program, honestly, it's easier to do this with a drill, a couple cordless drills, and whatever you use for your screw, whether it's a number 3 Phillips or a torque head, okay? You will literally go faster than running the machine to do it, alright? In my opinion. Now, we now need to construct a program for the actual millable surface, okay? And before we get to that, I will give you one little quick tip here. If you're in the market, when you're buying your material, once you have your dimensions, your spoiler board coverings never change. They're always going to be the same size, okay? You can buy extras. You can cut them down to size that you need. Like I said, this one was, okay, 16 3/4, these are 14, and our widths are always 37. You can buy extra ones. You can make them up, you can cut them, you can mark your lines on them, you don't have to put them on the machine. You can drill them out, you can get them all set, and you can put them in the back room so you have them. You have extras set aside, okay? No different than your stock or your material, your screws, your glue, your paints, your polys, whatever. And you've got extra spoiler boards sitting in the back room so that when these are bad, you go into the back room, you swap them out. Okay, that was my tip. Now, to take us to the actual milling process of this, okay? Like I said, we'll include a video with Rockler. You don't need to watch the machine run, okay? We need to find the millable surface. Well, to start with, we know that the board is 37 inches wide, that our spoiler board is 37 inches wide. Now, my particular machine, I told you that when these machines are made, your gantry, you can use your gantry with, I run a Win CNC controller. I can initialize my machine back, I can zero the machine out, and I can run the gantry up the y-axis, slow it down to the end because you don't want the thing to crash, you don't want to damage your stepper motors or your gears or your track. Slow it down, and I'm almost positive that I max out at 50 1/4 inches. Well, that's going to carry me over into my end spoiler board plate. I don't mill it. I just don't. I have plenty of space. I end up with 47 inches just by milling these 3 using a pocketing tool path. I have more than enough engraving room on just these 3 spoiler boards. I end up using the 2 on the end as a workspace. We own a little wood shop, so we try to make use of everything we have, alright? So I would take, from my starting point, and I would go 47 inches. That would be the start of my program on my Y. If you need, you can write it down on your machine. Same thing again. Once you've zeroed out, you can now run the head of your router across the x-axis on your gantry, slow it down towards the end. It's going to give you your maximum travel. Come back a little bit as far as your measurement, and I'm pretty sure mine is 37.5 inches on the X. All right? Now, half of 47 will be 23.5. I'm going to come down where my middle line is, because this is the middle of my machine. I'm going to come down the middle. I am going to come down 23.5, and I'm going to make a mark. Okay? 18.5 is the middle of the machine. On the x-axis, 23.5 is half of 47, which is half of my millable space that I want to do. My machine happens to have a laser crosshair, okay? This, I can't recommend one of these enough, okay? If you don't have one, there is a way around this. We'll discuss that in just 1 second. Okay, I can find my, oh my goodness, I'm working backwards here, goodness gracious. Okay? There's my center. This is the center of the X and Y. On my Win CNC controller, I really can't see it from here. Laser X0, Y0, and it would move the head, because this laser is calibrated to the center of the router head, to the router spindle. It'll put me dead center where I want it, okay? Now, if you don't have a laser, what you can do is you can make a mark with your pencil, and you can put in a very sharp, like a 60-degree V-bit. You can put that in, and you can just lightly touch the center with that V-bit, and then you can origin it at X0, Y0, raise the gantry back up, and now you're ready at that point. Let me get this out of the way. Now you're ready at that point to put your spoiler bit in, okay? Not everybody has a laser on their machine, so this is just, using a little V-bit is just, it's an extra step, but it works, okay? I've used it on other people's machines when I've gone to give them a hand with something, all right? Now, as far as the spoiler bit goes, they pretty much will all do the same thing. Some of them cost more than others, because the bigger your spoiler board bit, the higher it goes up in money. I run a 1.5. I use a 50% step over, so that every time I do a pass, my first initial pass will be 1.5 inches, and every step thereafter will be 750 thousandths. So it'll be half of the width of the spoiler board bit, okay? This is MDF, okay? It's medium density, so it's not like you're milling mahogany, okay? You can run your bit at a decent speed, okay? But I use a 1.5. These are about 30, 35 bucks. They're very cost effective. They're very reasonable. I also use these when I plane down the slabs for the headboards on these new log beds we're building, okay? You would insert it like any other bit. You could come down, you could touch top. Maybe you've got a touch top plate, okay? Regardless of what your situation is, touch your top. Again, the larger the spoiler board bit, the more money you're going to pay. They make these pretty big. You can get them with replaceable blades, but you can go from 30 bucks to 300 bucks pretty easy, okay? So I stick with the $30 ones. They don't make me cry as bad, okay? All right. Well, guys, the next thing we're going to do is we're just going to show you a quick program. We'll run the simulator on the software. Our software for this example is VCarve Pro through Vectric. It will also, I believe it will be applicable to Cut 2D, and it will also most certainly be applicable to Vectric Aspire, which is going to be our upgrade down the road, all right? Well, you guys hang on a minute. We'll get our program, we'll get it cut, and we'll run you through the steps in which we're going to do to mill the board, all right? We'll be right back, guys. Thank you very, very much.